It says study the matter in figure 2. Assume the particles are uniformly distributed throughout each object and particles of the same size have the same mass. So again, we could use this little key here. I'm going to say that this circle is going to be equal to 1 gram. In the table below, show how the masses, volumes, and densities compare by having less than, greater than, or equal to in the statement. Explain your reasoning. So we're going to do the exact same thing as question 1. And if you forgot, less than looks like this, greater than looks like that. So let's do the first one. It says mass of A to B. So if we look at A here, it looks like there's 1, 2, 3, 4. It looks like it's 13 grams again. If we look at B, it's 5, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. This looks like it's 27 grams if I'm counting. All right, so 4, 8, 12, 5, 10, 15, perfect. And then C, if I'm just going to start counting, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. It looks like I have 23 grams in C, right? And so make sure you double check and count for me. I have 5, 10, 15, and then 8 is 23. So for mass now, A compared to B, I could easily do this. It looks like B is larger in mass. And then A compared to C, looks like C has a larger mass. And the reasoning, more circles in B and C compared to A. Now let's look at volume. So if I look at A and B, we have that same situation as we had in the first one. Let's say this is 1 milliliter. I think B is approximately twice the size of A, so let's call that 2 milliliters. But look at C now. It looks like it's the same volume as A. We're going to call that 1 milliliter as well. So for the volume of A compared to B, again, B is larger. But look at A versus C now. Both A and C are the same volume. That's equal. They take up the same space. So for A and B, B takes up more space. But for A being equal to C, A and C are the same space of matter. That would be the explanation. All right, now finally, we've got some densities here. We're going to go ahead and calculate these densities based off of the numbers that I have here. Let's do the density of A. For A, we have 13 grams divided by 1 milliliter. That's 13 grams per milliliter. For the density of B, we have 27 grams and 2 milliliters. 27 divided by 2, that's about 13.5 grams per milliliter. Almost about the same. And then let's do the density of C. The density of C is 23 grams divided by 1 milliliter. That's 23 grams per milliliter. Let's highlight those densities. A has a density of 13 grams per milliliter based off of the numbers that I have here. Look at this. B has a density of 13.5, and C has a density of 23 grams per milliliter. So now let's compare A to B. For the density of A to B, I mean, it's like approximately equal. If you wanted to, you could say that A is less than B slightly. I would accept both, right? They're approximately equal, 13 and 13.5, maybe depending on how I'm counting the circles. I would say maybe 13.5 is a little bit larger. If not, with human error and measurement, it could be about the same. Now let's look at A and C here. A and C do not have the same density. It looks like C has more mass in a given volume. So I'm going to say less than. And we have the data here. C has the largest density. We could also say C has more mass in a given volume. That's why it'd be the most dense. So that wraps up question 2.